Imagine you're a factory owner. One morning, you walk into the production line and notice something is off. Wasn't line A supposed to produce 500 units yesterday? Why did the warehouse only receive 450? Where did the other 50 go? Which machine made them? Which worker was on duty? What was the raw material batch number? If your only options are to call the floor, flip through paper logs, or rely on a veteran worker's memory, congratulations, your factory is experiencing a nightmare that every manufacturer knows all too well. This nightmare has a name, the factory black box. From the moment raw materials enter to the moment finished goods leave, you have absolutely no visibility into what happened in between. And that is exactly where today's topic comes in. MES, the Manufacturing Execution System, is a spotlight installed inside your factory, turning that black box into transparent glass. Let me start with a restaurant analogy that everyone can relate to. If ERP is a restaurant's ordering system, tracking what customers ordered, the total bill, and today's revenue, then MES is the kitchen management system. How many cooking stations are active, the machines? Which chef is handling each station, the personnel? Are ingredients stocked enough, the materials? How far along is each dish, the work in progress? Was the dish prepared according to SOP, quality inspection? MES makes all of that kitchen information visible in real time. Its formal name is Manufacturing Execution System. Its mission, in one sentence, track every step of the production process in real time, from raw material to finished product, with a complete record. According to the international standard ISA-95, a factory's information architecture is divided into 5 levels. Level 4, ERP, managing inventory, procurement, and finance. Level 3, MES, our topic today. Level 2, SCADA and HMI, supervisory monitoring systems. Level 1, PLC, programmable logic controllers. Level 0, sensors, measuring temperature, pressure, and rotation speed. MES sits right in the middle. It bridges ERP above and shop floor equipment below. It acts as the translator, converting the management's production plans into work orders the floor can understand, then reporting actual output back to ERP for inventory updates. The International MESA Association has identified 11 core functions of MES. But you do not need to memorize all 11. Just keep in mind 3 most important use cases. Use case 1, product traceability. If a customer returns goods claiming there is a defect, without MES you would have to spend hours digging through 3 months of paper records just to figure out which batch, which machine, and which worker was involved. With MES, you enter a product serial number, and within 3 seconds you can pull up the complete production history, material source, process parameters, inspection results, and shipment time. This is a baseline requirement in food safety, pharmaceutical manufacturing, and automotive parts. Use case 2, OEE equipment efficiency analysis. You have 10 machines, but do you actually know how much of that time they are genuinely producing? Many factories run at less than 60% equipment utilization. MES automatically calculates OEE, overall equipment effectiveness, so you know whether each machine is producing, waiting for materials, under maintenance, or just idling. You cannot fix what you cannot see. Use case 3, production scheduling visualization. No more Excel-based scheduling. MES lets you see the real-time progress of every work order and the load on every workstation, and can even automatically calculate the earliest possible completion time. According to a Markets and Markets research report published in 2025, the global MES market was valued at $15.95 billion in 2025. And is projected to grow to $25.78 billion by 2030, with a compound annual growth rate of around 10.1%. Major vendors include Germany's Siemens Opcenter, US-based Rockwell Automation's Factory Talk, France Dassault Apriso, and other large players such as Honeywell, ABB, and SAP. In Taiwan, Advantech offers iFactory MES. DigiWin provides its own MES solution, and semiconductor giant TSMC even has its own in-house MES system. The reality, however, is that traditional MES implementation costs are extremely high. Deploying a full MES suite for a mid-sized factory can cost anywhere from 500,000 to 2 million new Taiwan dollars, with timelines ranging from 6 months to 2 years. That is why many Taiwanese SMEs still use Excel for scheduling and paper for records. It is not that they do not want to upgrade, the barrier is simply too high. So you have decided to implement MES. What is the first step? It is not about buying software, and it is not about calling vendors. The first step is figure out what you actually need. Most failed MES projects share one root cause: poorly defined requirements. So how do you do requirements analysis? Here is a simple 4-step process. Step 1. Map the current state. Walk to the production line and follow a work order from beginning to end. Document every step: who makes which decisions, what tools they use, where they record things, and where data is stored. You will be surprised to find that many so-called processes are just habits passed down from veteran workers, not formal standard operating procedures. Step 2. Identify pain points. Talk to the floor workers, not the boss. Talk to the operators, quality inspectors, and warehouse staff. They know exactly where things get stuck and where mistakes happen. Common pain points include materials that are hard to locate, schedules that change constantly, quality records that get skipped, and defects found only after the shift ends. Step 3. Define core requirements. Convert pain points into functional requirements. For example, materials that are hard to locate becomes real-time material location and inventory lookup. Quality records getting skipped becomes setting up an electronic inspection form at each checkpoint that blocks progress until completed. Step 4. Prioritize using MOS-COW. Not everything needs to be done in Phase 1. Use the MOS-COW method: must have, should have, could have, and won't have for this phase. Typically, Phase 1 should focus only on product traceability and data collection. Other features can be added incrementally. Once requirements analysis is done, the next step is to turn requirements into system documents. Here I want to introduce a practical methodology called Spec Shield. Its core principle is plan thoroughly first, then iterate incrementally. You may have heard of waterfall development and Scrum. Spec Shield combines both. Use waterfall thinking to fully define requirements, then use Scrum to iterate on development. It produces documents in 3 phases. Phase 1, the Product Requirements Document, or PRD. This phase answers 3 questions: who will use the system, what features are needed, and what does success look like. You will produce 8 documents: product overview, user personas, functional requirements, non-functional requirements, roadmap, user stories, business logic, and a risk register. In plain English, Phase 1 turns what is in your head into black and white specifications. Phase 2, the System Analysis Document, or SA. This phase answers: what will the system look like, how will the database be designed, how will security be handled, and what will the user interface look like. You will produce 7 documents: System Architecture Diagram, Database Schema, Security Design, Interface Specifications, UI Design, and Observability Design. In plain English, Phase 2 turns what you want to build into how you will build it. Phase 3, the Technical Specifications, or specs. This is what developers actually read: API endpoint definitions, data dictionary field descriptions, and error code design. After each document is produced, you need to do multiple rounds of self-validations, checking that numbers, names, and IDs are consistent across all documents. This step is critical. In every project I have run, each round of validation finds at least 1 or 2 inconsistencies. Today we started from a factory scenario, and we covered what MES is, what problems it solves, how to conduct requirements analysis before implementation, and how to use a systematic approach to design specification documents. You might be thinking, this all sounds very technical. Can I really do this on my own? The answer is yes, but take it one step at a time. MES is not a product you install and forget. It is a system that requires continuous iteration. The most successful implementations did not try to do everything at once. They started with one production line, one feature, got it running smoothly, and then expanded. In Taiwan, More and more small and mid-sized manufacturers are taking digital transformation seriously, and MES, as the core of a smart factory, is an excellent place to start. If you are planning a similar system, I hope today's framework, map the current state, identify pain points, then use the spec shield methodology to produce documents step by step, gives you something useful